Hi, I am Donalek, and this is the first lecture on machine learning as part of the JPL Caltech Virtual Summer School on Big Data Analytics. Machine learning is a very exciting and broad field with application in the industry and in many scientific domains. Actually, we use the outcome of machine learning algorithms every day without even knowing it. For example, when we use a search engine or read what Netflix is suggesting for us to watch, we are just looking at the outputs of machine learning algorithms running in background. Now, the overall goal of these classes is to give you a set of tools and teach you how to use them. In this first lecture, I'll give you definitions for machine learning, data mining, and knowledge discovery in databases. Moreover, we'll go through the different types of learning and the tasks that can be accomplished. Now, let's start with an historic definition given by Arthur Samuel, an American pioneer in the field of computer gaming and artificial intelligence. Machine learning relates with the study, design, and development of the algorithms that give computers the capability to learn without being explicitly programmed. Arthur Samuel was actually the first one that wrote a checkers program that actually won against one of the best players at the time. That event is regarded as one of the milestones in the artificial intelligence field. Now, more recently, Tom Mitchell, professor at the Carnegie Mellon University, gave a more formal definition. A computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. Let's see a real-life example. Every day, our mail client sorts the incoming mail for us. The mail client is actually using a machine learning algorithm in which the task T is recognizing spam. Experience E can be represented by the user flagging email as spam, not spam, or retrieving emails from the spam folder. P can be seen as the percentage of correct classification. Other common applications are in computer vision, science, medical diagnosis, and so on. For example, when you use face detection to automatically tag people in your picture, you are running a machine learning algorithm. Also, most of the advertisements you see while browsing are shown based on the likelihood you will engage with that product, and this likelihood comes as output from machine learning algorithms. Now, let's see why we need a machine learning approach and when it can be employed. This course has a focus on big data. Big data is often described using the 5 V's. Now, the first 3 are self-defining. Huge volumes are being created at ever-increasing velocity, coming from a variety of sources. The fourth, veracity, is related to the messiness of the data that comes in a way that accuracy and quality are less controllable. Think about harvesting tweets and Facebook status to find out about how people feel about a particular topic. But it is actually the fifth V that is related to machine learning, and it is value. Of course, having access to big data is no good unless we can turn it into value, and that means be able to extract knowledge from the data. Now, when a machine learning approach should be used? There are 4 main reasons. First, we want to extract knowledge. That means finding interesting patterns, look for outliers or peculiar objects, and so on. Then, we know that a pattern exists, or at least we hope so. Third, we cannot actually pin down the problem using formulas, otherwise we will just be solving equations, and machine learning may be just not the recommended technique. And finally, we have data. Let's not forget that machine learning is a data-driven approach. Now, suppose we have our data. what kind of learning can we apply? Now, machine learning algorithms can be divided in two big classes, supervised and unsupervised learning. Also, other types of learning has been proposed and are commonly used, like semi-supervised, reinforcement learning, transduction, or learning to learn. Now, in the next lectures, we'll go in more details through the different types of learning. In this introductory lesson, I'll give you just some quick definitions. So, let's say that we talk about supervised learning when for some of the samples, the desired output is known and it is used during the training process. We talk about unsupervised learning when the model is not provided with correct results during the training phase. So they can be used to cluster the input data in classes on the basis of their statistical properties only. And so unsupervised learning is commonly used for clustering and search for outliers. And then semi-supervised learning combines both labeled and unlabeled examples to generate an appropriate function or classifier. Now, there are many algorithms that can be applied, and you need to choose the right one for your needs. That's because in machine learning there is no one-size-fits-all solution. That's why often we need to try multiple models and see which one gives the best results. Some of the most supervised and unsupervised models are shown in the slide. Supervised models like neural networks, Boltzmann machines, decision tree, nearest neighbors, Bayesian classifier, and unsupervised algorithms like k-means, self-organizing map, fuzzy clustering, and so on. Now, choosing the right approach and the right algorithm is not an easy task. And we need to answer some questions like what is being learned? How data is generated? Is there any missing or incomplete data? Because some models can be applied in presence of the missing data, some others are not. How the data is presented, one at a time, all in once, and what is the ultimate goal? Now, let's see the relation between machine learning, data mining, and knowledge discoveries in databases. First of all, let me say that machine learning and data mining are often confused or used as synonyms. From now on, we will refer to data mining as the process of extracting knowledge and interesting patterns hidden in large dataset. During this process, machine learning algorithms are used. And what do we mean for interesting? Well, that depends on the problem addressed. But in general, we look for non-trivial, previously unknown, and potentially useful data patterns. Now, in this slide are listed the most common data mining algorithms. All can be addressed using machine learning models. So it's classification, regression, forecasting, clustering, search for outliers, also called deviation analysis, path analysis or sequence analysis, and association, also known as market basket analysis. Now, classification is one of the most popular data mining tasks. In a classification problem, we want to divide our samples in classes and assign each new object to a given class. The goal is usually to maximize the percentage of the samples correctly classified. Classification will also be covered in more details in one of the next lectures. Now, regression is in some way similar to classification. The main difference is that the predictable attribute is a continuous number. Linear regression and logistic regression are the most popular methods. And for example, regression can be used to predict coupon redemption rate based on the face value, distribution method, and distribution volume, or to predict wind velocity based on temperature, air pressure, and humidity. While in a clustering problem, we want to partition our dataset in subsets that ideally share some common characteristics, and no single attribute is used to guide the training process. Deviation analysis is for finding those rare cases that behave very differently from others. These may be just errors, but may also be a completely new type of object and lead to a Nobel Prize. Also, clustering will be covered in more details in one of the next lectures. Now, another data mining task is called path analysis. In path analysis, we look for patterns in which one event leads to a later event. For example, in web path analysis, we can mine log files to get knowledge about how visitors use a website. Then we can generate a set of rules that can predict which users are likely to click on a particular link or make a purchase. In the sequence analysis, also the order is important. For example, buying a desk before buying a chair is different from buying a chair before buying a desk. The last task we see today is association. In the association analysis, we try to find inherent regularities in data and ask questions like, what items are most frequently purchased together? This is widely used in setting up shelves at the grocery stores. And in fact, one of the most cited stories in literatures tells that a survey conducted by a grocery chain eventually discovered that customers who buy diapers tend also to buy beer. This anecdote became popular as an example of how unexpected association rules might be found from everyday data. And in association, the order is not important. All the items are equal and independent. Now, data mining and machine learning are part of the knowledge discovery in databases, or KDD, that can be defined as an iterative process of discovering useful knowledge from a collection of data. The diagram in the slide shows the steps in this process, starting from the data and ending with knowledge. In the next slides, we'll see these steps in more details. Now, the first step is gathering data. Data can come in different forms, from sensors, instruments, humans, and often from multiple sources. So the first problem to address is usually how to merge this data. The second step is the so-called data cleaning, where we deal with noise, decide how to handle missing data, and put data in a format that can be easily ingested by a machine learning algorithm. The next step is data reduction and transformation. Often we have data sets with hundreds of parameters, and the goal of this step is to reduce the dimensionality. These three steps are often referred as pre-processing. Then we have the actual data mining part. First, we need to choose the right task and test one or more machine learning algorithms in order to achieve the best results. Then we need to evaluate the results and interpret the discovered patterns. Eventually, we can apply this knowledge to solve our problem. Now, so far, we have defined the machine learning and data mining and went through the different types of learning and data mining tasks, such as classification, clustering, path analysis, and so on. Then we have started talking about the KDD steps, and we'll see them in more details in the next lecture.